Good morning, everybody, and welcome to episode 9. Today's episode, I'm going to discuss space weather. Space weather is just the variation in the space environment between the sun and the earth. The reason we need to study it because we need to see the impact of the space weather on systems and technologies in orbit and on the earth. So this next picture that you are looking at is the space weather phenomenon. So as you can see, there's actually quite a lot of space weather that comes from the sun and between the sun and the earth and the effects that it has on the earth. So I'm just going to discuss a few solar flares. These produce strong X-rays that degrade or block high frequency radio waves used for radio communication. So this is also known as a radio blackout storm. So you can't communicate at all when this occurs. No signal will go through, no radio wave signal will go through. Solar energetic particles. These are energetic protons. These penetrate satellite electronics and cause electrical failure. So when you're building satellites or rockets or anything electrical, you need to take into consideration these energetic protons. So what usually happens is you have the electrical failures are grouped into like single event effects and multiple event effects, because you need to see whether it only affects one part of the system or it's going to affect multiple and how far that goes. There's also total ionizing dose and displacement damage dose. So these are some of the main issues that come with the electronics, or that cause problems that caused due to these energetic protons on the electronics. Solar energetic particles also block radio communications at high latitudes during solar radiation storms. Coronal mass ejections. So these cause geomagnetic storms at Earth and induce extra currents in the ground that can degrade power grid operations. So these mostly affect transformers. So this can have massive blackouts. There's actually two major ones actually that have occurred. The first one was in 1859. So this was during the time when they had telegraphs. Essentially, all the telegraph systems went down of the whole Western world. Basically, they were on fire. And another one that occurred was in Quebec, March 1989. Most of the Canadian systems, or the Quebec systems, went down the grid, and also part of the US grid, more or less New York area, because they got, essentially you're supplying power sometimes to neighboring countries, and if one goes down, then it affects other parts of the grid which have to produce more, and it goes down as well. So it was actually a far-reaching implications. And when this occurs, it takes a while to fix. So essentially you could think of it as load shedding, but due to coronal mass ejections. Another one is geomagnetic storms. These affect the accuracy of GNS and GPS systems. So it actually affects the signal and how it reaches the devices, the receivers here on Earth. So you can actually get the wrong location of where you are. Maybe, I don't know about how much, but it can affect a whole lot of things like flight systems and the stock market. That's critical. Those are critical things that we can't lose. They also produce the aurora, actually. So the aurora can be split into two things. Two of them. There's the aurora borealis, which is in the northern lights, and the aurora australis, which is in the southern lights. So auroras are just results of electrons colliding with the upper reaches of the Earth. So you see these beautiful lights that are wonderful to see. Coronal holes. So looking at the picture, these are just dark areas in the solar corona, in the extreme ultraviolet and soft X-ray solar images. So we always like to take images of the sun to see what is going on, and we take different electromagnetic pictures to get different understandings and views of the sun. The coronal mass ejections. So as I said, these are just large expulsions of plasma and magnetic fields from the sun's corona. That's all there is to it. Earth's magnetosphere. So the magnetosphere is just a region of space surrounding the Earth where the dominant magnetic field is the magnetic field of the Earth rather than the magnet. You could think of this as our shield in some ways. It protects us from the harsh space environment, environment and ejections. And this is very important and critical. Obviously, it's not perfect because there are regions of radiation that occur around the Earth, and there's also, we can still get affected if the sun's space weather is too strong. But it is important for us to live on Earth. The ionosphere. So this is between 80 to 600 kilometers in the Earth's upper atmosphere. So this is where solar radiation causes ionization, which creates a layer of electrons that can affect Earth systems. That's very important. As you can see, there's a whole lot of things that we could be affected by, and it's very deep. Solar wind. So this is a continuous outflow from the sun and consists of protons and electrons in a plasma state. So it's always there. It can actually create like a drag on your satellite, depending on how close you are to Earth. If you're very close to Earth, there's a very minimal effect. If you're very far away, there's a huge effect. So the geo satellites actually have to counteract for that with their control systems for the solar wind, because your satellite actually drifts, and if it drifts, then you don't have a clear line of sight to where you need to see on the Earth. So as you can see, there's a whole lot of space weather that affects us, both our satellites and here on Earth, that can cause major damage. If satellites go down, the Earth systems go down. If the Earth systems go down, satellites can essentially continue on working. That's actually the nice thing in a way. SANZA does actually have a space weather center here in South Africa. So if any of you want to go and investigate more, look into that. And space weather, at the end of the day, is very important when we come to human exploration. So human exploration, we have to look at protecting them, protecting the astronauts. We have to look at early warning signs, especially for solar flares, because electronics can really get damaged, and if something fails in space and you can't fix it, that's it. Unless there's a rescue mission, but that depends on how far you are away from Earth or the moon in the future, in case we build a base there. And we also need to sort of create maneuvers, so ways to reduce the effect, maybe the way we align with it, or our protection maybe is at the back of the spaceship, and we sort of need to maneuver our way to make sure that the solar flare maybe hits the back of the spaceship to reduce the effects and things like that. Thank you for watching. So the next episode, I'm going to discuss what is my master's research on and what other students have done in Space Lab.